Hey everyone, welcome to Online Education Academy today. On today's lesson, we'll be using mupad, which is a MATLAB tool that is used to solve mathematical problems. Use mupad to show that the limit as x approaches infinity of e to the power negative ax, and then given this condition for infinity, to show that the answer is infinity for a is less than 0, 1 for a is equals to 0, and 0 for a is greater than 0. So they are giving us a hint here. Hint, use the function assume to distinguish the cases. Okay, fine. So they've given us a hint of what to use. Let's go straight ahead to mupad. Now we are here on mupad because they say we use assume. So we're going to use that assume. So we're going to say assume. The first assumption is what? Then we go assume a is less than 0, right? So going to assume that a is less than 0, and then that's the end of our assumption, right? Assume that a is less than 0 for what? For the limit, and then for e we say exp, and then of what? Of negative a times x. It's negative ax, right? And then x is equals to infinity, because our x approaches infinity. Infinity. So this is it. Then we put our semicolon. Then we check our assumption. Then we found infinity, right? So for our assumption for a is less than 0, we find infinity as an answer. Let's go and check in our code. Yeah, if we check here, for the limit as x approaches infinity of e to the power negative ax, when a is less than 0, it is infinity. So we got that one right. For a is equals to 0, we must get 1 as our answer. Then let's go again, and then we can simply copy this assume, control copy, then we paste it, control V to paste. But now here we'll change the assumption when a is equals to 0. Then let's check what is our answer. Then we put enter. Then we get 1 as our answer. 1 is our answer as expected, because x is approaching what? Infinity. This x is equals to infinity because x approaches infinity. Okay, and then there's one more case, right? As expected, when a is equals to 0, we have 1 as our answer. And then for a is greater than 0, so we have to do that. Right. So this hint, it helps us a lot because we use the assume to distinguish between the case when a is less than 0, when a is equals to 0, and when a is greater than 0. Please subscribe if you're getting value on this video. Type in value in the comment section if you're getting value from me. To receive more content from me, please subscribe. So let's continue with our last part. For the last part, we can copy again this assume function, control copy, then control V, then we paste. But now instead of less than 0, we're gonna say greater than 0. So assuming a is greater than 0, then we get 0 as our answer, as expected. So our answer is infinity, 1 and 0. So let's check in our question. So we must get infinity, 1 and 0. So by doing this, we have solved the problem using mupad. So this is our final answer. Yeah, so we use the assume function because they said we must use the assume function. For a is less than 0, and then we have our semicolon, then we have a limit. For exp is for exp, and then to the power of minus a times x, because that's what we are given, comma, this comma now states the condition. So the condition is when x approaches infinity, x is equals to infinity. When x approaches infinity, then our answer is infinity. Then we do the same thing. We assume when a is equals to 0, and then our semicolon, the limit exp minus a times x, comma, x is equals to infinity, then we get 1 as our answer. Then we assume a is greater than 0, semicolon, limit exp minus a to the power x, comma, x to infinity, then we get 0. Thank you very much for your time. Please subscribe for more learning content. This is how to solve this problem using mupad. Thank you very much, and type in value in the comment section. I love you all.